In this video, I'm going to be talking about Lab 11, which is Boyle's Law. Boyle's Law is looking at the relationship between pressure and volume. So, all gases are subject to four conditions. Their behavior is affected by changes in pressure, and pressure units usually are in millimeters of mercury or atmospheres, ATM for short. Volume, which is measured in milliliters or liters if it's a larger volume. Temperature for gas laws has to be always in Kelvin, especially when you're solving gas law problems. This can lead to a lot of error if you have the temperature in degrees centigrade. So make sure that you're always converting temperature to Kelvin. And then the fourth condition is moles of gas or amount of gas. Okay. So these are the four conditions that affect the behavior of gases. So we're going to keep these two constant for this experiment, temperature and moles, and look at the relationship between pressure and volume, and that's Boyle's law. So Boyle's law says that the pressure of a gas is inversely related to the volume, provided you keep the temperature and the N, which is the moles of gas, constant. So that means that if pressure increases, volume will decrease. If pressure decreases, then volume will increase. So that formula for Boyle's law is, if you multiply pressure and volume, you get a constant factor, and also make sure that the temperature and number of moles are constant. Now this Boyle's law can be rewritten as P1 V1 is equal to P2 V2. Okay. The units of pressure, as I mentioned before, are ATM, atmospheres, or millimeters of mercury, and units of volume are in mils or liters. Okay. So what's P1? P1 is the initial pressure, V1 is the initial volume. So the initial pressure times the initial volume should equal the final pressure, P2, times the final volume, V2. So in this experiment, you're going to take a 150 ml Erlenmeyer flask, double click to close it, attach a pressure gauge to the flask so that you can monitor the pressure, then drag from the materials tab a canister of propane to the flask, fill it with 1 ATM of gas. So the total volume of the gas is going to be 150 ml because gases just occupy the volume of the container in which they are kept. Okay. So now to this flask add 20 ml of water. If you do that, what will happen is now the air or the gas is confined to a smaller volume, which is 130 ml. Okay. So now record this new volume of 130 ml and then look at the pressure gauge and look at the pressure for this volume. So the volume is coming down, so the pressure should be going up. Now you're going on adding water in 20 ml increments 4 more times. So the final volume of water will reach 100 ml. So you start out with 20, and so a total of 5 portions of 20 ml. So you'll get up to 100 ml of water. And when that happens, the gas volume is reduced from its previous 150 to 50 mils. So then the pressure will also increase as well. So make sure at each step you're recording the volume and pressure. For the experiment 2, again, you're repeating this but with a different gas. This time it's butane. So you're taking the flask, attaching the pressure gauge, taking the canister of butane and filling the flask with this is a typo, it's 1 atm of gas. So now again the total volume of the gas is 150 ml, and then you're going to add 20 ml of water, reducing the volume of butane to 130 ml, record the pressure, and again in the same way keep on adding 20 ml increments till the volume of water reaches 100 ml, and the volume of butane now is reduced to a final volume of 50 ml, and at each point you're recording volume and pressure. So then if you look at the numbers, you will see that at 150 ml of the gas, this is experiment 1, so that's propane, the pressure was, again this is a typo, I'm not sure why that I did that in a couple of places. It should be ATM, there's no such thing as TAM for measuring pressure. So it's 1.01, so roughly about 1 atmosphere. Now when the volume decreases to 130, the pressure slightly increases to 1.1 or 1.2, and then again as that volume is decreasing you can see a gradual increase in the pressure until at the last point when the volume is reduced to 50, the pressure is increased to 3. So the pressure has steadily increased, so between 1 and 3 atmospheres. Now when you plot pressure versus, this is not volume, it is 1 by volume, so it's 1 divided by volume. So this is an error here in the x-axis label, it should be 1 divided by volume. All right, so when you plot pressure in atmospheres, again another typo, it should be ATM. So pressure in atmospheres versus 1 divided by volume, then you get a straight line. If you were to simply plot the pressure versus volume, you would get a curved line, because as the volume is decreasing, the pressure is increasing, so it would look like a curved line rather than a straight line. So this is 1 divided by volume, so make sure you do that. Okay, and so you will see that you get the straight line, and then they ask you to check what the corresponding pressure is when the volume is 75 ml. So 1 divided by 75 ml is 0.013, so that should be around here. And then if you look at the corresponding pressure, this is around 2 atmospheres. 1 divided by 300 is 0.003, which is around here, and then you will see that the corresponding atmospheres is 0.5 atmosphere. Okay, so as I said before, as that volume is decreasing, you can see that the pressure is going up. Now you don't have to get these numbers from the graph. You can do this using the P1 V1 equals to P2 V2 formula as well. Okay, so this experimental data verifies that the Boyles law from the graph P pressure versus 1 by volume, when it was plotted, it's a straight line, and that verifies the law, showing the inverse relationship between pressure and volume. 75 ml corresponded to 2 atmospheres on the graph, and then 300 ml corresponded to 0.5 atmospheres. Again, as I said, you can do this using the actual formula, the P1 V1 is equal to P2 V2 formula, instead of reading it off the graph. So in the second experiment, when you did the same experiment with butane, you can see that the numbers are so similar, all right? From 150, by the time you get down to 50 ml, you can see that same trend. The pressure is increasing between 1 and 3 atmospheres. So again, when you plot, I'm saying it correctly down here in my notes, pressure versus 1 by V, but then my label is incorrect here, all right? So it should be 1 divided by volume, not just volume, all right? So again, if you look at 75 ml, right? So 1 divided by 75 ml, that should be about 0.013, somewhere in here. And if you bring it up to the line, it cuts across on the y-axis at 2 atmospheres. 300 ml, all right? And that should be about 0.003. And then if you again plot a line, or you draw the line, the perpendicular line to cut the plot on the y-axis, it corresponds with 0.5 atmosphere, right? So again, butane and propane both behave exactly the same because they're both ideal gases, and all gases that are ideal gases behave exactly the same. Okay, so that's why the numbers are exactly the same for both gases. So both experiments had identical results. They showed that they follow Boyle's law. The constants in the experiment are temperature and moles of gas. So in a real lab situation, when volume decreases, pressure will increase and temperature will decrease. Okay, so pressure and volume, temperature and volume have a direct relationship, whereas pressure and volume have an inverse relationship. So what was the aim of this lab? The aim of this lab was to determine the relationship between volume and pressure for two gases, propane and butane. So my hypothesis, my prediction is that both gases, as their volume decrease from their initial 150 ml to 50 ml, the pressure will be rising gradually because of the inverse relationship between pressure and volume. Make sure you list all your equipment and write down your procedure. And then after you write down your procedure in detail, then write down your observations. And as we mentioned before, as the volume of gas decreased from 150 to 50, the pressure was gradually rising from 1 atmosphere up to 3 atmosphere. And again, this is identical for both gases. Okay, so this was the data that was observed for propane gas, and then the plot kind of looks a little weird here, but you can see when you plot it, the 1 by V, and we already discussed this. If you look at where 1 divided by 75 ml, which is the 0.013 falls, and then you bring up that line up to the y-axis, that corresponds to atmosphere. And then 1 divided by 300, which is 0.003, and then again it cuts the plot on the y-axis at 0.5 atmosphere. And we'll have to stop here and continue this in the next video.